Today we're going to talk about the arc length of a circle. We're on page 3 of our chapter 10 notes. Remember that an arc is just a portion of a circle, so any little part of the outside of the circle is called an arc. Well, an arc length is calculated with this little tiny formula that's called S is equal to theta times R, and what these letters mean is S is the length of this arc. So if you wanted to measure this like using measuring tape, or if you remember our paper plate, we used a string to measure around the outside. So S is the arc length. That's pretty important. Theta, of course, is the measure of the central angle, and it has to be measured in radians or else this formula doesn't work. So theta is this angle, and you can see right here we've got an angle that's measured in, this is 1 radian, here's another radian, here's another radian. So theta is the second part, and R is usually stands for the radius of a circle. And remember, the arc length and the radius have to be in the same units. Units meaning centimeters, inches, feet, miles, whatever you're using, you have to make sure that they're both in the same units. For example, in this picture that's drawn kind of lightly, you can see that there are 3 arcs that are measured out. Here's an arc that's 2 centimeters. Here's a second arc right here that's another 2 centimeters. And here's another arc that's another 2 centimeters. Or if you wanted to call this entire arc our arc, then this whole arc is 6 centimeters long. So that's what this indicates up here, that you have a big arc that starts from here, goes all the way around to here, and that's a 6 centimeter arc. So in this diagram, this arc is length 6 centimeters. Now this circle has a radius of 2 centimeters. That's what's indicated on here. And if you have a 6 centimeter arc and you have a 2 centimeter radius, if you remember from our paper plate activity, we measured the length of the radius, and then we measured out 1 arc length that's equal to that radius, and that would give us an angle that's 1 radian. So this 1 stands for 1 radian, and this angle right here is another radian, and this other arc over here, this other angle is another radian. So altogether we have an angle of 3 radians. 1, 2, 3 radians. And you can use this little formula here. S, the arc length of 6, is equal to theta, which is 3 radians, times 2, which is the length of this radius. So that's the formula that you can use anytime you need to figure out one of these 3 values. You'll be given 2 and asked for the third. Here's a little example. If we want to find the circumference of a circle, and if you remember the circumference formula from geometry class or another math class, if you remember, circumference is equal to 2 pi r. Hopefully you remember that. Well, you can use this formula to get this 2 pi r, because in class we learned that there are 2 pi radians in 360. If you remember, 1 pi went around to 180, so there are 2 pi radians in 360 degrees. So if we want to know the arc length of the entire circle, which is the circumference all the way around, this S value, this arc length, is equal to the angle, which is 2 pi 360 degrees, or 2 pi radians, times r. So in this particular circle, if we wanted to figure out what the circumference is, in this particular circle, it is 2 pi times the radius, which is 2, and so that is 4 pi centimeters. And if you wanted to figure out exactly how many centimeters that is, you can just press on the calculator 4 with a little pi after it. So 4 pi is about 12.566 centimeters. 4 pi is 12.566 about. So let's go through these 3 examples when we're going to be asked to find one of those 3 values. In example 1, we're told that the radius of the circle is 4 centimeters. So we usually circle the important things. And up above here we say r equals 4 centimeters. A central angle, remember the central angle is theta. The central angle of the circle intercepts an arc of 12 centimeters. Well, S is the arc length, so S is equal to 12, and we look, this is centimeters and this is centimeters, so they're both in the same units. So we have an R and we have an S. We want to know how many radians are in this angle. So we use a little formula. S is equal to theta times R. Our S is 12 is equal to theta times our radius is 4. And so if you divide both sides by 4, that'll give you 12 divided by 4 is 3 is equal to theta. So the radian measures is 3 radians. And that's the answer to this question. What is the radian measure? Well, the second part says, is 3 radians acute, obtuse, or larger than a straight angle? Larger than a straight angle being more than 180 degrees. Well, let's see. We're going to figure out how many degrees in 1 radian, because you know that an acute angle is between 0 degrees and 90 degrees. You know that an obtuse angle is between 90 degrees and 180 degrees. And if it's larger than the straight angle, then it's greater than 180 degrees. So we're going to figure out from up here, 3 radians, how many degrees there are. So here's a formula that you can use. 3 radians is what's given to us. And what you can multiply that by is that you know there are 180 degrees in pi radians. That's an equation. 180 degrees is equal to pi radians. Well, this is unit conversion. If you want to put a 1 underneath that, the radians will cancel out, and what we have left is 3 times 180 divided by pi, and that's how many degrees are in 3 radians. 3 times 180 degrees divided by pi. Well, I don't know what that is, but my calculator does. So we can use this 3 times 180 divided by pi. Well, there's 171.887 degrees in 3 radians. So that's 171.887 degrees. Well, that's an obtuse angle, because that falls in our obtuse range. So that's how you can always convert from radians to degrees. You just can multiply by 180 degrees is equal to pi radians. That's an identity. Example 2. We have a radius is equal to 8 inches. So r equals 8. We have, they're asking us for the length of the arc. What is the length of the arc, which is S? So they're asking us for S, intercepted by a central angle, which is theta, and the central angle is pi over 6. So theta is equal to 5 pi over 6. So we use our S equals theta times R. They're asking for S. Theta is 5 pi over 6. R is the radius, which is 8. So we can just ask our calculator, what is 5 times pi over 6 times 8? So I'll use my fraction button again. 5 times pi over 6 times 8. And it looks like it's 20.944, about. So 20.944, and what is our units? Our units are in inches. And it doesn't ask us to round in any particular way, so I'll just put 20.944. I don't think it says rounding it. All right. So we're almost done here. Hang in there. We have one more example to go. Let's see if I can focus this. Example 3. Now we're running into a little problem here because we have a central angle of 135 degrees. And what we need to do is say, whoa, 135 degrees, we have to convert that to radians, or else our formula won't work. All right, so the first thing you do if you're trying to figure out one of these three things, if you're given an angle in degrees, you got to convert it to radians, or else this whole thing is not working. So how do you convert 135 degrees into radians? Well, you can multiply 135 degrees, this is unit conversion, and remember there are pi radians in 180 degrees. Or you can do like we did yesterday, 135 divided by 180, math frac, 135 divided by 180, math frac, and then we're going to put a pi on top of that. So let's do it that way. That's what we did yesterday in class, or on the video. 135 divided by 180, math frac. Oh, we have 3/4 coming up. So our theta is equal to 3 pi over 4 radians, and that's what we need, not degrees. And what else do we have? We have an arc length, which is S, is equal to 10. So our formula says S is equal to theta times R, and our S is 10. Our theta is 3 pi over 4 times R. Well, how are we going to solve this for R? Well, we can do it a whole bunch of different ways. I think what I'm going to do is I'm going to multiply both sides by 4, because if you multiply by the denominators, they cancel out. So 4 times 10 is equal to 3 pi R. I'm going to pull that up here. 4 times 10 is 40, is equal to 3 times pi times R. And now I'm going to divide both sides by 3 pi. And use your fraction button, otherwise you're going to have to put parentheses around the 3 pi, or else you're not going to get the right answer. So I always use my fraction button, then I don't have to worry about parentheses. 40 divided by 3 times pi is going to be our R value, and that looks like it's 4.244. And it says round to the nearest tenth, so I'm going to say R is equal to 4.24. I'm going to give it out to the hundredths place, but to the nearest tenth, it is 4.2 centimeters. So there's our answer, 4.2 centimeters. So there's a lot of information on here, but the big thing is degrees will not work with this formula up here. Theta has to be measured in radians, or the formula won't work. So please add that onto your notes up here, radians. Okay, and that's it for today. Nice short video.